Hi folks, I'm Adam, your instructor. Welcome to the Laney College Machine Shop. Today, we're going to be working on the Finder Scope project for Machine Tech 210, the introductory course in machining and manufacturing. Specifically, we're going to be working on the tube, which is essentially the primary structural component of the Finder Scope, to which all other components assemble. In a previous video, we performed all the lathe operations, so at the moment, the part looks like this. But in this video, we're going to perform all the hole-making operations on a milling machine, so the part will end up looking something like this. Before we get started on the machine, let's just take a few moments to review the features on the three-dimensional solid model and the specifications on the drawing. We've already looked at the three-dimensional solid model. It's basically just a fancy tube with various inside and outside diameters. The features that we're concerned with in this video are the holes, one more or less in the center of the tube, and three which are equally spaced around the circumference of the tube toward one end. Alright, here's the drawing. Since we've also looked at this before, we'll jump straight into the views. And I'm going to remove all the information that doesn't directly have to do with the holes, so we can simplify this drawing a bit. In the front view, which is also a section view, we can see that there is a threaded hole specified with 1/4-20 UNC 2B threads, which only goes through one side of the tube and is located at a distance of 3 inches 220 thousandths from the left side. We can also see that there are some threaded holes at a distance of 775 thousandths from the left side, but these are not easy to see in this view, so there's a cutting plane line which passes through the centers of the holes to generate another section view shown on the left. This view makes it much easier to see the holes' profiles and their orientations relative to one another. These are specified with number 632 UNC 2B threads, which only go through one side of the tube, and they are equally spaced at 120 degrees apart around the circumference of the tube. Okay, that's pretty much it for the print. I think we're ready to start making some chips. Let's head out to the shop. Let's gather up some tools. We'll need a number 4 high-speed steel center drill, a number 36 high-speed steel twist drill with a diameter of 107 thousandths, a number 7 high-speed steel twist drill, which has a diameter of 201 thousandths, a 1/2 inch high-speed steel countersink with an included angle of 90 degrees, a 632 tap, a spiral flute tap in this case, and finally a 1/4-20 tap. This one is a plug tap with 4 straight flutes. Okay, we're onto the mill and we've got our part. Looking pretty good so far. We're going to use this special work-holding device called an indexing head or indexing spacer. Just like the mill vise, this device also has keys on the bottom for aligning it to the T-slots in the table. So go ahead and clean off the bottom of the indexing head and the top of the mill table, and flip the indexing head over so that it's sitting on the table and the keys are in the T-slot. We'll need 2 each of the following: T-nut, stud, step clamp, step block, washer, flange nut. Assemble the stud into the T-nut. Next comes the step clamp, followed by the washer, and finally the flange nut. I'll show you what we do with the step blocks in just a moment. Install this assembly through one of the T-slots in the mill table. Set the non-serrated side of the clamp down on one of the horizontal surfaces on the indexing head, and then slide in one of the step blocks and set the serrated end on top of that. I'm going to slip one of these aluminum shims underneath the step block so that it can span the T-slot in the table. At this point, I should stop and mention 2 very important nuances when using hold-down clamps like this. The first nuance is about the angle of the clamp. Other than perfectly horizontal, there are 2 options for the clamp: tipped slightly forward or tipped slightly backward. Between these two, tipped slightly forward is more desirable because this way the clamping pressure is still directed downward. When the clamp is tipped slightly backward, it contacts the edge of the object being clamped, and so only some of the clamping pressure is directed downward. It also pushes the object being clamped sideways, to the left in this view, and that's not what we want. The second nuance is about the position of the stud and nut which apply the clamping pressure. Again, there are two options. The stud can be biased toward the object being clamped, or it can be biased toward the step block. Between these two, biased toward the object being clamped, in fact as close to the object being clamped as possible, is more desirable, because this way most of the clamping pressure is directed onto the object we want to clamp. When the stud is biased toward the step block, then most of the clamping pressure is on the step block, which is not the thing we care about. It's only there for support. So this configuration here looks pretty ideal. Go ahead and get the nut finger tight. Then go ahead and install the other hold-down clamp assembly on the other side of the indexing head. Just find a horizontal surface which is out of the way but will effectively hold down the indexing head. And get it finger tight. There's a little bit of clearance between the keys on the indexing head and the T-slot on the mill table, so we'll need to push the indexing head backward so that the keys contact the back of the T-slot. Then use a 7/8 combination wrench to tighten down the flange nuts. Alright, just so that the chuck jaws don't mar our finished part, we'll install these copper shims. They just slip right over the jaws. Then we'll install the part in the 3-jaw chuck, holding on to the 1-inch 380 thousandths diameter. The way that the indexing head works is that there's this little spring-loaded release lever, and when you press that down, you can spin the chuck. But what's more important is that when you let go of the release lever, the chuck will lock in, and the positions where it locks in are at exactly 15-degree increments. There are degree markings on the outside of the chuck and a 0 reference line on the body of the indexing head, so you can tell exactly what angle you're at. This is how we're going to get the 120-degree spacing of those 3 holes on the end of the tube. For now, just go ahead and set the indexing head at 0. You can see that the 0 degree mark and the 0 reference line line up with one another. Okay, let's install a drill chuck. Clean the tapers on the chuck and on the spindle. Then stick the drill chuck into the spindle, reach up and tighten the drawbar by hand, then stick a 3/4 combination wrench on the end of the drawbar, engage the spindle brake, and tighten the drawbar. Okay, install an edgefinder into the drill chuck, and crank the X-axis table feed over to position the spindle kind of toward the chuck. Then crank the Y-axis saddle feed to position the spindle behind the part. Bring the quill down so that the middle of the tip on the edgefinder is at the center line of the part. Then move the table in so that the part contacts the tip of the edgefinder and causes it to go concentric and then pop out. Like that. Now folks, it does look like we may have a bit of a clearance problem here. It looks like the reduced diameter on the tip of the edgefinder is where it's touching the part, but that shoulder is awfully close. This diameter, the diameter of the part, is a little over the practical size limit for this type of edgefinder. So going forward, I'm going to recommend using a different style of edgefinder without a reduced diameter on the tip. Just FYI, the diameter of the tip of this edgefinder is a 1/2 inch. Anyway, go ahead and 0 the Y-axis on the DRO. Bring the quill back up, and then move the table so that the edgefinder is on the other side of the part. Then move it back down to approximately the same location as before, and then move the table to touch off on this side of the part as well. Now press the 1/2 button on the DRO, followed by the Y-axis button. This will set the Y-axis 0 to halfway between where we zeroed it on the back of the part and where we touched off on the front of the part, meaning that the Y-axis 0 should now be on the center line of our part. And that's what we want. So go ahead and lift up the quill and then move the table to the Y-axis 0. all of our operations are going to be at this y-axis position, so go ahead and lock the saddle so it doesn't move. Okay, now we need to find the edge on the end of our part, so go ahead and crank the x-axis table feed so that the edge finder is just a little bit off the part. Drop the quill, and then feed the part along the x-axis so that it pushes up against the reduced tip of the edge finder, and it goes concentric and then pops out. Zero the x-axis on the DRO right there. Then lift the quill back up so the edge finder clears the part. So what we need to do now is move over an additional amount equal to half of the diameter, or the radius, of the tip of the edge finder, which just happens to be 200 thousandths, so the radius would be 100 thousandths. So go ahead and move the table over 100 thousandths now, and then re-zero the x-axis on the DRO. Okay, from here we can find our first hole location, which is at 3 inches, 220 thousandths. Right there. Just to be safe, go ahead and engage the table locks so it doesn't move around on us. And let's take out that edge finder. Since we're going to be putting a lot of downward force on the part, we're going to use a screw jack like this one to support the end. And actually, first I'm going to put one of these 1, 2, 3 setup blocks underneath the screw jack. And then raise the screw jack so that it just touches the bottom of the part. We don't want to over torque this because then it'll push the part up. Alright, let's install the center drill. Turn the spindle on, apply some WD-40, and then spot the hole location. Remove the center drill, and now we're ready for the number 7 twist drill. Oh, but it looks like it won't fit, so we'll need to drop the knee with the hand crank so that we can get enough space to stick that drill up in there. That should do it. Yeah, nice. Go ahead and install the drill. A little WD-40, and then drill through, just the one side, not all the way through the tube. Brush off the chips, and then remove the drill. Now we need the countersink. Install that into the drill chuck, turn on the spindle, apply some WD-40, then bring the tool down to countersink the hole. And we're not looking for much of a countersink here, folks, just a little bit bigger than the major diameter of the threads. And we can measure this with a dial caliper, just kind of measuring from one end of the countersink to the other. It looks like this is around 280 thousandths, which is 30 thousandths of an inch over the major diameter of our threads, which is a 1/4 inch, 250 thousandths. So this is perfect. Okay, remove the countersink, and we're actually done with this hole for now. We'll come back later to tap it. Now let's move to the second position where those 3 holes are located, and that's at 775 thousandths. Right there. By the way, I'm not showing this, but I am unclamping and reclamping the table locks, just so that the table doesn't drift off of position as we're doing our holes. Okay, let's get to it. Spot the first hole with a center drill. Now let's install the number 36 twist drill, and drill through one side. Again, not drilling all the way through the tube. Before we index the part, let's back off the screw jack. Push down the release lever, and then rotate the chuck to the 120-degree position. Let go of the release lever, and then just make sure that the chuck actually clicks into place. The 120-degree mark should line up with the 0 reference line now. Then reinstall the screw jack and bring it up just to touch the part. Again, we don't want to over torque this so that it deflects the part up. And let's do it all again. Spot with the center drill, drill through one side with a number 36 drill, loosen the screw jack and move it out of the way, index the part another 120 degrees. So now the 240-degree mark should line up with the 0 reference. Reinstall the screw jack, and repeat one more time. Spot with the center drill, drill through one side with the number 36 twist drill, and now we've got 3 drilled holes, so let's countersink them. These holes are smaller than the first one, and the threads are also going to be smaller. These are going to be number 6 32 threads rather than 1/4 20 threads. The major diameter of number 6 threads is 138 thousandths. Right now, our countersink measures 163 thousandths, which is 25 thousandths over the major diameter of the threads, and that's plenty, so we'll call that good. Just so that we don't have to do any more guess and check when we countersink the other two holes, bring the countersink down until it touches the countersink that we just made on the hole. Then zero the z-axis on the DRO at that spot. Now all we have to do is bring the countersink tool down to that same 0 point, and the countersinks will end up the same size, or at least very, very close, on the other two holes. Easy. Alright, let's index the part another 120 degrees. You should be pretty familiar with the song and dance at this point. The 0 degree marking should be back at the 0 reference now. And then countersink that hole. Bring the countersink down just to where we set the z-axis 0. Okay, let's index the part again. And then countersink that hole. That should be all of them. We're going to need to drop the knee even more to fit all of our tapping tools between the drill chuck and the part, so go ahead and crank that down now. Then install the spring-loaded tap guide into the drill chuck, and install the 632 tap into the tap wrench. Make sure the V-grooves on the jaws are engaging the square drive on the end of the tap, not the round cylindrical portion on the shank. Tighten it down good and tight, and then stick the whole tap and tap wrench assembly between the tap guide and the hole on the part. Bring the quill down to preload the plunger on the tap guide in the divot on the end of the tap wrench. Apply a good amount of WD-40, and then tap away. As always, if you feel a little bit of resistance, back the tap off to break the chips, and then keep going until you get through the hole. This looks like we've gone far enough. The tap is all the way through the hole, and we're past the sort of lead chamfer on the end of the tap, so we know that we've got good threads all the way through the hole. Now back the tap out of the hole, and we'll index the part to the next hole. And repeat that process. One more index. And repeat the process again. Okay, those 3 holes are done, but remember we still have to tap the 1/4-20 hole. So let's move back to that one, which is at 3 inches 220 thousandths from the end of the part, if you'll remember. And now let's load the 1/4-20 tap into the tap wrench. Otherwise, the process is exactly the same, so go to town. You don't need me for this. All right, remove the screw jack and unclamp the part. This one is in the bag. Well, I guess there are a few more processes that we have to do to this part, like black anodizing and pressing in the threaded insert, but in terms of machining, we are done. So congratulations on getting this far, and I will see you in the next video. Thanks for watching.